chemical reactions in organic chemistry. So we are very familiar with different chemical reactions in inorganic chemistry. That's why yesterday I presented diba, plenty small fish, right? Yeah. Bullet ever. Mm. While discussion, while discussing, let's take a bite on Bolinao. Okay? Okay. This is gonna be like okay. Now, chemical reactions. Reactions in organic chemistry. Organic chemistry. So let's exercise and practice. Okay? Oh. So what will be our example? Okay, for example, benzoic acid plus ethyl alcohol. Oh, really? How can we manage that one? So number one, benzoic acid okay, plus ethyl alcohol. Okay? So what really comes on our minds today, we will put because I don't prepare. Okay? Things like that. So it's just like biglaan, okay? Get the point? Because I was jolted in the morning. Oh, how about you doing about chemical reactions in organic chemistry so that it would be a little bit different. Okay? Number two will be, let's say, chart. Okay, we have, how can we do this? Okay, butyric acid. Wow, what's this butyric acid all about? Okay. Butyric acid is found in, dairy products like cheese, pasta, macaroni, like that. And then also sometimes, not sometimes really, it's in mayonnaise. You know that one? Mayonnaise. So dairy products. Okay. And then sometimes also when you, not sometimes, technically when you put like meat in the refrigerator, right? And then the oil will become sticky or it will be precipitated like a white color, things like that. Okay, so it's gonna be like there's a butyric acid there. Okay, so the purpose of butyric acid is really healthy for our body in the digestive system because it will provide as a source of food of our bacteria, good bacteria, our biome part in our digestive system. Get the point? So because all people have the good bacteria, the inherent good bacteria inside our body. Okay, so they need also to survive there. Okay, they love to survive with, eating low digestible carbs that rich in fiber usually. So these fibers food that we eat, should we say, not in daily basis, I know that also. Okay, like citrus fruits or whatever, or low carbs like that. So it will be good to our good bacteria inside our body. Okay, things like that. And then butyric acid is very important for them also. Then it will come convert it to butyrate like that. Okay, fiber, rich in fiber food, for example, yogurt, things like that. But I also believe that not all is adaptive to this, okay, because others also will have the side effects or other symptoms that may be felt. But I'm just talking in a scenario in which understood to be for all healthy people with no any other symptoms, things like that. Okay, so this would be good. The butyric acid. So butyric acid plus, let's say, uh, propyl alcohol. Okay. So, suggest a chemical reaction and let's do this in organic chemistry. Number 3, we have, oh, really? So, glyceric, wow, glyceric acid plus methanol, wow. Okay. Glyceric acid plus methanol. Okay, for the record guys, this is the first time I balanced this kind of chemical reactions for my entire life. That's why I told you on the spot. Okay, methanol. Okay, I'm not doing this when I was in my college years, in my chemical engineering days. Okay, because we normally balance only the inorganic compounds. I think there is also, but I just forgot. But with my own intention, not really planned like that. So this is the first time. Okay, things like that. In the moment I wake up, my brain cells suggested, oh, Sotero, let's blog about chemical reactions in organic chemistry. Okay, let's say ethanoic acid. Okay, ethanoic. Oh, really? Yes. Ethanoic acid plus sodium bicarbonate. Wow! Sumobra ha. Sodium bicarbonate. Okay. Like that, no? Okay, then let's try also. Okay. Sodium. Sodium ethanoate. Wow! Sodium ethanoate. Grabe naman to. Okay, plus, let's say, calcium hypochlorite. So strange, right? Can we balance that one? Okay, let's say acetic. Okay, acetic acid. Acetic acid. Okay. Or let's have sodium citrate. Sodium citrate. Okay. Nakakaloka. Sodium citrate plus let's say oxalic acid. Wow. Sure ka, Jun? Yes. Kahit ano, let's try. Okay. Number 6, acetic acid. Okay. Acetic acid plus, let's say, sodium carbonate. Okay. Carbonate. Let's try a very unique for the first time. These are all for the first time. Okay. Number 7, acetaldehyde. Acetaldehyde. Oh my gosh. Plus, let's say, sulfuric acid. Okay. Sulfuric acid. Wow. 7 lang. Okay. Chemical reactions in organic chemistry. What we mean here, so even if there's a little bit of mixture with inorganic compounds, it's still okay as long as you blend that with organic compounds. Okay, here. Highly organic, benzoic and ethyl alcohol. Butyric acid, propyl alcohol, highly organic. Glyceric acid, methanol, highly organic. Ethanoic acid, highly organic, but sodium bicarbonate is inorganic. Sodium citrate, organic. Oxalic acid is gonna be, how can we identify oxalic acid? I think it's inorganic. Acetic acid can also be an inorganic, can also be a organic. This is vinegar. Acetic acid. Sodium carbonate, inorganic. Acetaldehyde, organic. Sulfuric acid, inorganic. So there's blended with both organic compounds and inorganic compounds. So how can we give you the chemical reaction for this? Okay, because the whiteboard is just very small, right? on. Hello guys. How can we do that? I have no space. Wait, let's do some magic. How can we do that? Let's erase the other, but I take screenshot. Okay? Because my whiteboard is very small. So how can I do that, right? So let's take screenshot and then we come back to other 2, 3, 4, 5, 6, 7. Okay? Like that. So let's go first with benzoic acid and ethyl alcohol. So how can you balance that chemical reactions? Okay. Guys, how can you balance that chemical reactions? Benzoic acid plus ethyl alcohol. So let's erase the other, no? Okay. Things like that. Erase. Oh my gosh. Benzoic acid. So how can we put this? It's gonna be C6H6. Let's discuss first the benzoic acid. Okay. So C6H6, right? And then it's gonna be plus the acid with COOH, right? Like that. Benzoic acid. Get the point. So how can you do that? So let's simplify this into carbon, double bond oxygen, and OH. Okay. Now, in this functional formula, and we have also the benzene here. Okay. So we have hydrogen. Okay, 6 atoms of hydrogen. Okay. And then we have hydrogen here also. Okay. So which do you think will give off the proton? This one, the carboxylic acid, or this benzene? Things like that. Okay. Take note. Okay, and here, where is the outlet to react? The oxygen or the OH? Things like that. Okay. Okay. It's very clear, right? How can we do this? So this clearly undergo the process of deprotonation. Meaning we need to remove one proton of hydrogen here from H6 to be displaced by our acid here. Okay, you get the point? So it will now become C6H5. The other hydrogen will be displaced. Things like that, okay? With COOH. And then the other one will be going there, the H. Here. The other side. We take away the H of this one and we go to the other side. Okay. Get the point? Ganon. Okay, so this is gonna be this one, the product, this one. This one will not be stable to H plus, so this will become H2. Things like that. Okay? And later you will balance, but our target only is to determine the chemical formula of benzoic acid. No need to balance. So that's why this is our formula of benzoic acid. Okay? Things like that. Okay, C6H5COOH. Really? Yes. C6H5COOH. Nakakaloka. Now, plus ethyl alcohol. So that's gonna be C2H5OH. Right? So it's gonna be like that. Okay, so take note that benzoic coming from the benzene C6H6. Okay, the moment you will add the acid, it will become benzoic acid, right? I don't have to show the reaction because it will take a longer time. Let's focus here. Okay, things like that. Now we need to put a division. Okay, in this manner. So here, H, we need to put like this in order we can determine where is the element to be displaced. Actually, it is double displacement and double replacement chemical reaction. Things like that, no? Here also, subdivision. Okay, because this is a compound like that. Okay, things like that. Now in your acid, you need only to get the H because from the C double bond oxygen OH, it's in the H in the OH ion that it will react the other compounds. Here. No structural formula of our carboxylic. This is carboxylic acid. This is OH. Okay. Then in the OH part, other substances will react to the H. Okay. Get the point? Ganon. And displaces, ganon. And then it will yield water somewhere along the way. Okay? This COH is the same as C double bond oxygen OH. Okay? Like that. Now you will try to move this. This one is what we call this C2H5. What's this all about? This is alkyl. So alkyl, right? So if you say alkyl, so alkyl, ganon, is equals to alkane, okay, minus 1 the hydrogen level. Things like that. Get the point? That's the formula. Alkyl is equal to alkane minus 1 in terms of hydrogen atom. What do we mean by this? For example, this is taken from ethyl alcohol. You will say the backbone will be ethane, C2H6. We will say alkanes, C2H6 minus 1 hydrogen atom. It will become C2H5 because in our formula we deducted the hydrogen atom, not the carbon atom. That's why C2H5 is put here. Okay? Things like that. That is alkyl here. Okay. So that will be our R, the side group of simply ROH. All alcohol follows this functional formula, ROH. R is our alkyl, this one. Then it will become C2H5. So we just put directly the C2H5OH. That's why it's here, right? Ganon. Okay. So in this situation, okay, you remove the hydrogen or you displace the hydrogen with something. So it looks like this is gonna be dehydrogenation. Possible names of your chemical reaction. Dehydrogenation, because you remove the hydrogen and change that with other, or you displace that with another one. Dehydro. The effect of displacing this. Go first this with dehydrogenation, huh? Step 1. Okay, so we will change this reactant, this, so the H1H will be deprotonated. Okay, so this is also deprotonated. Possible names of the chemical reaction in actions we get. Right? Okay, since we are deprotonating the positive of this hydrogen, so it will be lost now in the benzoic acid. Say, transfer now to it. C6H5COO C2H5. Okay. That's the point. Now, because you transfer, right? Now, is this appropriate to say C6H5COO C2H5? In the Yupak rule of International Union for Pure Applied Chemistry, we need to put first the alkyl in the here, the beginning. So you say ethyl, okay, ethyl benzoate, okay, like that. Ethyl benzoate, and this is now COO. If you see COO in the books, in different sources of science or chemistry or organic chemistry or whatever, then that would mean ATE. Okay, benzoate, glycerate, aspartate, citrate. Oh, okay, there's a lot, guys, no? Ascorbate, malate, butyrate. Okay, so there's a lot. Okay, so this one COO, huh? Don't forget this one. Okay, plus, then since you lose already the ethyl, it was transported and displacing the hydrogen here, so it will now become OH. Okay, then transfer that with H. So it's now HOH. What's that all about? HOH, very obvious in organic chemistry. How many hydrogen? 1, 2. So H2. How many atoms? 1. So H2O. Okay. The product is H2O. So this is talking about the products, right? Now, since you are yielding water, what is the process of yielding water? This is also called hydration. Okay, hydration. Okay, hydration. Or in similar manner of hydrolysis, which will mean salt and water, but in this case, this is not salt, this is ester. This one. Okay? So this one, ester is the salt of carboxylic acid. By definition, fabricated definition with sense. Okay? Because the books will never tell you about that. But if you try to understand, it's gonna be like that. See? The salt of carboxylic acid, because this ethyl, see, this benzoic acid is your representative acid of the carboxylic acid, and then you yield an ester. So common sense to say, or you will say ester of carboxylic acid, general, and you will say ethyl, see, okay, ethyl benzoate. Okay, ethyl benzoate from benzoic acid specific. Again, general. Okay, so to avoid confusion, we need to change the salt to ester now. Okay, but what I'm trying to emphasize, the analogous action will be the same. Okay, but to be specific now, you will say ester of carboxylic acid. This one. Okay. Then general. And you will say specific. Okay. Ethyl benzoate is an ester of benzoic acid. Specific. Okay. So in the meaning of general, try to express only the functional formula or the general formula. Okay, that speaks for all. In the same family like that, how to apply. Okay, then water. So since you are producing water in a product, that could also be hydration. Anything you produce water in the product, by logical approach, it's hydration. Then you remove water, that's dehydration. Right? So we are enumerating here the processes involved in this particular chemical reaction, benzoic acid plus ethyl alcohol. Now, number 4, since this is the product, right? So, the most specific process for this is esterification. Esterification, because it produced ester after the chemical reaction of benzoic acid plus ethyl alcohol. So, esterification. Like that. Wow. Now, if you have an analogous discussion pertaining to inorganic chemistry, this will be also double displacement and replacement, but in the context of organic compounds. Get the point? So, but we don't include that because there's a lot of words to be done. Here only, so the hydrogenation, the protonation, hydration, and esterification. But the esterification is the popular chemical reaction in this. It when asked in a question in an examination, but we don't know really also in the future which of the following chemical process, chemical reaction does not belong to the group in this chemical reaction, benzoic acid and ethyl alcohol. And the choices will be A, dehydrogenation, B, deprotonation, C, hydration, D, esterification, E, none of the above. Oh, maglibog ka because you are only familiar with esterification for organic chemistry. So that's why you need to maximize our terminology knowledge building. You got the point? So that would be the benefit. Okay, so the moment you do your chemical reactions, okay, as shall I say, as legit chemists and legit chemical engineers, we should really be clever of the maximization of the terminologies to be used. Not only one. We should not be at the minima, on the minimal level. We should be in the maximum and maximal level. Charis, right? Okay. So very comprehensive discussion, shall I say? Okay, the time will not be enough. I will be discussing the whole thing. That's right. Okay, got the point. So it's gonna be too much in my brain cells, so I cannot share everything. Okay, so this is gonna be like just the backbone of our understanding. So this is not a product. Okay, so you yield water at a product. Okay, now, so this is esterification reaction. Now, you will have a summary now based on your presented chemical reaction from benzoic acid plus ethyl alcohol. You will say esterification. So therefore, we can say, okay, carboxylic acid, okay, plus alcohol, okay, will yield ester plus water. After you've done the chemical reactions, you can formulate a general reaction statement. Oh, it's gonna be like that. So you have to follow this every time. That every time you meet chemical reactions that really falls into this category, then you need to use this only, so that you don't have to think too much in your mind. So this is only you can pattern and you can use this all the time. For example, if I will say, what is the chemical reaction of malic acid plus nonanol? Okay, it looks like strange because it reaches to nonanol. You got the point? So you have to follow this one and bingo. And you understand the general formula, functional formula, structural formula. So it will be really enjoyable to do such thing in which you love the most. You got the point? So anything in life, if you enjoy something, so you know, even though you will not prepare on the spot like that, it's easy to discuss. Okay, it's easy to elaborate and it's easy to elucidate something extensively and meticulously if you have really the backbone of the understanding of the specific knowledge for that particular context or topics in chemistry. And here is chemical reaction in organic chemistry. So every time we will be engaging with an acid and alcohol, okay, then follow this one. So that is esterification reaction. These three are only an indicators that we need to do this reaction before yielding this esterification. See, you will do our dehydrogenation by removing the hydrogen. You need to do the deprotonation because one proton of hydrogen has been displaced, and hydration because you produce water in the product out of these two compounds here. Right? Okay. Things like that. Any questions so far? Nothing, right? Okay. So, this is our, but now, take note mga palangga, it's not yet finished. Okay? So we are only predicting the products. We don't know yet if this is balanced. Okay. So this is ethyl, okay. This one benzoate, okay, benzoate. In salt in organic chemistry, that is ATE, the same thing, but you know, in ester it goes like benzoate. You have OATE, okay, OATE. Like for example, ethanoate, like that. So this is now ester, huh? OATE versus ATE. Okay. ATE, OATE are the indicators to distinguish, okay, see, an ester and a salt. The difference only ester have letter O in the first letter, and the salt, there's nothing, only ati. So if you say ati, o ati ester, ati acid. So ati is inorganic acid, or inorganic salt, sorry. O ati is organic salt, or what we mean as an ester. But because if you try to dig it out, an ester really is an organic salt. But it is precise to use the name ester. We use only that as an indicator that we can understand that the behavior of an ester is just like a similar in salt inorganic. Okay, but the specific name to use is ester. You get the point? Technical term. Okay, things like that. You get the point? So, in this manner, ethyl benzoate plus water is your product. Word. Because we start with words, we also produce the words. Okay, benzoic acid plus ethyl alcohol is equal to ethyl benzoate plus water. And then this is the chemical reaction, and you also produce a chemical reaction in terms of formulation. I hope also teachers will do this. The first thing to do, put the statements. The second thing, put the chemical formula so that the students also have a wide knowledge how to deal with chemical reactions. It's not all the time putting the chemical reactions like that. So this is to master really in expect the unexpected examination in the future. That sometimes they don't really put the chemical formula and the reactants by chemicals. They will just put the words, and you'll be the one to balance everything. And so this is a good practice as a beginner, okay, like that, as a neophyte, wow, as a kalos, as a first timer, like that, okay, that we need to do this comprehensive steps in determination of our chemical reactions. Okay, products, determination of products. Okay, things like that, right? Okay. Okay, muna siya, no? Benzoic acid. Now, if we try to, this is really condensed lang siya, no? Condensed structural formula, see, condensed. C2H5C6H5COOH. This is just only the one form of chemical reaction. We're not talking the structural formula, full structural formula, skeletal formula, Howard projection, Fisher projection. There's a lot to explore regarding chemical reactions because this, okay, structuring, the types. Okay, you can put this benzoic acid in a cyclic ring. I'll show you, Okay, let's copy for this. Okay, I think you know this already. Okay, especially BS chemistry students and chemical engineering students, right? Pagtagulinaw. Itong pag-aana ng ating brain cells. Okay. Erase. Thank you so much for watching for this. And before we end this vlog, okay, carboxylic acid na condensed formula, COOH plus, okay, plus ROH, okay, like that, is equal to ester, okay, RCOOR plus water. Water is specific, so H2O. And then carboxylic acid, there's also an R here because this is the representative of the element you bond or whatever. So RCOOH plus ROH is equals to RCOOR plus water. R would mean the attachment of anything. Could it be alkyl, compounds, organic compounds, other organic compounds, or other substances. Like that. So this is the general formula. Okay, if you try to structure this also in another manner, it's gonna be R, single bond carbon, double bond oxygen, single bond OH, plus R, single bond OH is equals to R, single bond carbon. Okay, like that. Then double bond oxygen, OR, single bond R. So as you can notice, the structural formula of showing, we need to emphasize the single bond, double bond, triple bond. But in a condensed way, we don't show that here. Okay, so condensed is more easy compared to structural formula. But if you don't have an idea about structural formulation, so you will find difficulty, especially if the tests or the chemical reactions there are written in statements, not showing the chemical formula. Okay, and then it's also condensed, problem for you also. You get the point? Things like that. So better we know the structural formula because we can orient somewhere else where to go. Oh, I need to put the oxygen at the top. Oh, I need to put the hydrogen at the bottom. Oh, what will happen if we'll add a paint in a chemical reaction? You know, a paint, a flammable paint. Things like that. So what will happen? This will explode or not? Okay, things like that. Oh, okay, this is polar. There's a chance of higher flash point. Things like that. They will mix a lot of knowledge in your brain cells in one chemical reaction only. You will play a lot. Very imaginative. So that's why to become a legit engineer is having a wild imagination. You will never become a legit engineer if your imagination is limited to something. It should be more than for something. For example, if I am here inside a room, my knowledge will be more than the four corners of the room. It will expand in an outside perspective. Like, for example, if I have subjects like this, for example, philosophy, logic, anthropology, psychology, then the teachers will discuss something about that, right? Then it's not enough there. I will go to other venues that are more macroscopic in nature, meaning the library. I will go there, things like that. I will attend a conference related to that particular topic. I will go to the website to research more. I will refer other books and other references. So meaning to say, your school life will not end with classroom discussion only. Trust me, this is really the okay, most of the probable to become a successful and a licensed engineers or licensed in other professionals. Because if you try to limit yourself in the classroom instruction, your option there is to fight more in the review, the last stage. You do a lot of review, 6 months review, 5 months review, and that would not be enough because that's not accumulation of knowledge. You will accumulate your knowledge from the basic to the last step of your educational level. But we should forget the elementary because we are just playing at the time. So it should start in high school. The building of knowledge. To put that in the pool. P-O-O-L. Pool of knowledge. Just like a swimming pool. Okay, then once it will be implanted and inculcated. Grabe naman itong term na ito, no? Inculcated into your brain, then